Hi, my name is Bhuvanand Barik and welcome to my YouTube channel. Today in this video we will be learning about entropy, which is used in decision tree in machine learning. So entropy means here is entropy is a measure of the randomness in the information being processed. It means it will check how pure the data set is. That's why I have written by measuring entropy the purity of the data set can be checked. We already know that in decision tree the algorithm is depending on the splitting of the features. So once one feature is selected and that feature will be splitted into the number of categories. After that it will be checked like how many labels are present in the dependent column. So suppose yes or no present in the dependent column, so how many yes, how many no, like that the purity of the dataset will be checked. So here by using entropy, feature of the dataset can be selected for splitting purpose. So if you see my previous video on decision tree, I have clearly explained how decision tree splitting is done. So when the feature is selected, that feature is selected based on the entropy and information gain. So what is entropy? In this video we will be seeing. Entropy helps in reaching the leaf node faster by selecting right feature. So as we have already discussed in the decision tree video, if right feature is not selected for the splitting purpose, if there are suppose multiple features are there, suppose 80 or 70-80 features are there, so out of so many features, if it is checked the feature randomly, then there is a possibility the decision tree may lead to a very complicated tree. So to reduce the complicatedness, here the entropy and information gain is calculated for each feature. Then based on the information gain result, right feature will be selected for the splitting purpose or for the proceeding of the decision tree. So that's why entropy helps in reaching the leaf node. Leaf node means the least node where there is no more splitting. So that leaf node faster by selecting right feature. Entropy is calculated for mentioned features in below dataset. So you can see there is a dataset given on the screen, and in that dataset there are various features present like age, student, occupation, income, and sale. And sale is here dependent feature or the target feature which will be calculated, and rest of the features are independent feature on the base of which the sale feature will be calculated, so that we can come to know like how much sale is happening or whether the sale will be done or not. So you can see in the screen there is question mark at the below 3 rows. Once entropy is calculated, information gain is calculated, I have already told. Then feature is selected for splitting purpose in decision tree. So like I can show you in the screen, if you see. So out of so many features, suppose we selected age feature, and so apart from age feature, suppose we are select there are so many various features. Occupation is there, student is there. So whether we should select student feature or whether we should select age feature or whether we should select occupation feature. Suppose we randomly picked this student feature. So in this student feature, when the entropy is calculated, we found there is lot of entropy or it is quite complicated. So it becomes quite complicated. So in that scenario, complication increases, so entropy also increases. And here also we found there is less entropy comparative to this one. But here entropy is quite less comparative to these two features. So this age feature is selected because we found less entropy. And not only entropy, after calculation of entropy, information gain is calculated. So that information gain result also actually tells which feature will be selected for splitting purpose. So here we are like splitting this feature. So here age is splitted into two parts, like below 25 and above 25, you can see on the screen. So if we check, if we are considering this below 25 below 25 records, there are 5 yes and 3 no present. So you can see these are 5 yes and 3 no, and in above 25 you can see there are 6 yes only. So if the purity comes, when we consider regarding the purity, 6 yes only means the data set is more pure, the subset of the data set is more pure comparative to this 5 yes and 3 no means it is impure. So here entropy is quite higher comparative to this subset. So this side entropy is higher. As it is higher entropy, it should be splitted further, and there is no need of splitting for this right hand side. So in this way, entropy is required for choosing the correct feature. Let's see the screen. So here, how the entropy is calculated, that is the most important thing here. The formula of the entropy. For binary classification, below formula of entropy is given below. The entropy formula is minus P of positive log base 2 of P positive minus P of negative log base 2 of P negative. What is P positive and P negative? Probability of positive class and probability of negative class. So here P positive means percentage of positive cases out of total cases. Suppose there are 10 records, and out of 10 records there are 7 records which are positive. So it means P positive will be 7 by 10. And if 3 cases are negative, it means P negative will be 3 by 10. So if the calculation will kept in this formula, then entropy can be found. Suppose there are 10 rows in which 4 counts are positive and 6 rows are negative. So in that situation, formula can be like this. So 4 counts is positive and 6 count is negative. You can see on the screen 4 counts are positive and 6 rows are negative. 6 rows are negative means the probability of positive cases are like, probability of positive cases will be like 4 divided by 10. So that is P positive. And negative cases will be 6 by 10. So it will be like P negative. So we saw like how P positive and P negative is calculated. Based on that, we can see if you simply put the, so simply here, once the P positive and P negative is kept in the formula, we found the entropy is 0.96, means 96%. 96% entropy means the entropy is quite higher. So if you simply put a common sense, you can see there are 6 positive, 4 counts are positive and 6 counts are negative. It means there is mix of both positive cases and negative cases. If simply only positive cases are there, or very less amount of positive cases are there, so in that situation we can consider uh, the entropy will be lesser. So if you consider like 7 cases are negative and only 3 cases are positive, in that situation it can be considered uh, the entropy will be reducing. So like this the entropy is calculated. Here if entropy is higher, then it is an impure subset. If entropy is low, then it is a pure subset. So as I have already told, if there is completely mix of positive cases and negative cases, or yes no, in that set the entropy is higher. In our set, like 4 cases are positive, 6 cases are negative. If it is like 5 cases are positive and 5 cases are negative, both are equal, in that situation the we can consider the entropy will be 100%, or the entropy value will be nearly like 98 or 99. So in that situation, if only positive cases are there, the entropy will be very less, or if only negative cases are there, the entropy will be very low, like some 20% kind of thing. So here if entropy is higher, then it is an impure subset. It means both cases are there, positive is there, negative is there, and they are equally there if entropy is very very high. If the subset contains only positive or negative cases, then purity is more, so less entropy. If both positive and negative cases are there, then more entropy. I have already told, if only one kind of data is present, then it is less entropy. If both data is present equally, and that is more entropy. You can see the graph on the screen, how the entropy, the graph is plotted between P positive and entropy. So from P negative to P positive, it is moving in the x-axis, and in the y-axis, entropy is increasing. So when it was only P negative, that time entropy was low. When it is only P positive, that time it is low. When positive and negative both cases are there, that time you can see the entropy is touching its higher, the crest is here. So in this way entropy varies. So there is one more example you can see on the screen, the feature which is containing both star and rhombus. Here there are two labels in the feature. Now feature is divided into two parts. As there are two labels, so it is divided into two parts. If there are three labels in the feature, then it will be divided for three parts. So here in one side, impure subset, so high entropy. In right hand side you can see the star mark is only there, and very very less number of there is no more rhombus in right hand side, only the star mark is there, so it is a pure subset. So in this way we can consider the entropy is calculated. And entropy is not the only thing which is calculated. Information gain is calculated apart from entropy. So how information gain is calculated, that we will be seeing in the next video. Once we come to know about information gain, then only we can clearly understand how the feature is selected based on the information gain result. So simply in layman term we can consider what is entropy. Entropy is a kind of hurdle, and the more the hurdle is, it is quite complicated to proceed in that path. So if the entropy is less, it is quite easier for the algorithm to proceed in that path and to create the decision tree and to take the decision. So here entropy, the less entropy is calculated. Based on the less entropy, information is gained. Once the information is gained, right feature is selected, and that particular right feature is splitted. After that, information gain and entropy is also calculated. Then also right feature is selected. So by selecting the proper and right feature, the decision tree is made and the decision is taken by the algorithm. So it was all about, this video was particularly about this entropy and its formula. In the next video we will be seeing what is information. If you like this video, please share and subscribe. Thanks a lot.